Okay, this one. Okay, so this is the summary report that the maintenance factor 0.85. Okay, and we are using 101 units for 165 watts. So what is maintenance factor 0.85? As we know that the lighting we installed, we not just use for one year or 2 years. So that's why the maintenance factor we put 0.85, which means we reserve 15% of the brightness, so that this brightness could be lasting until third years, we estimate, which means on third year you still able to have this type of brightness. Okay, so this is the 3D file, and this is the 3D file with the coloring chart. Okay, so this is the average lux level we have. Let's look at this rack hours lux. Okay, so on the rack, so this is the rack, right? So inside we put like a lux meter to verify, to measure the lux level or the brightness of the simulation lighting. So each point we have 135, 143, 144. Okay, so on average we have 142. Okay, and on the loading bay area, which means this is your warehouse and this is the loading bay area, you got 171. So maybe you ask why we put 171 instead of last time on the rack side 142, right? So because rack house area less activity. On this what to call the loading bay area, or so-called staging area, so it's more activity. So normally people will design that the open area having high activity, so we put the lux level more higher. Okay, so that's it for this summary report. So this PDF file we're going to share to yours lah. So on the simulation file, we would like to explain a bit over here. Okay, we can clearly see on this color chart. So red color area is 220 lux. So normally on warehouse, the lux level requirement on the standard is 150 lux. For Farmer Niaga, this is my ex-customer, so the request average lux level is on 200 lux. So I don't know, because it doesn't give me the lux requirement, so I, according the minimums design 150 lux for yours. But for the loading bay area, we design almost like 170 something lux. So this is the rack. Turn off the light, and you can clearly see this is the rack. Okay, so I turn on. Okay, so we zoom in the rack. So rack inside, you got 130 for blue color area. So green color area, you got 160. Okay, and some more, the lamp height, I also not sure about your lamp height. I estimate the standard design for warehouse on my past experience, the racks is 8.5 meter. I estimate. Alright. So the lamp we design on 11 meter. This is standard design 11 meter lamp height. So for the loading bay area, the lamp height design we put 7 meter. So I'm not sure whether you got the what's so called the HLVS fan, the very big fan, the high volume, low frequency fan. So if you got this type of fan, then I have to allocate the location also. You have to give me the AutoCAD file so I can put it. Alright, I think that's all for this. And I could tell you that another benefit for lighting is that we build in with sensors, right? So when you got people, you will turn on, no people, you will dim down or switch off. So in terms of heat emission, it have a very good benefit heat emission compared to non-sensors lighting.
So here's the explanation for the heat emissions saving. So from the explanation, we got two types of saving. So first is sensors product versus non-sensors products saving. The second one is the heat emission saving. Alright, heat emission saving. So first I would like to explain for the sensors versus non-sensors product saving. Normally, okay, on this floor plan, okay, very simply we can see that over here got 18 ounce. So normally the ounces have 18 ounce.
We estimate you got 5 forklift. So how was the calculation? So this is 5 ounces over 18, which means your occupation of the ounces is 27%. So 100% is 1. So which means our saving is 100% minus 27%. So this is our saving factor. So here is our calculation. Saving factor we put 72%. So this is the saving factor, which means nobody's on the ounces or warehouse is 72%. So the logic is 5 versus 8, 5 versus 8 from here. 5 forklift versus 18 ounce. Okay. So now this is non-sensors versus our product. Non-sensors versus our product Lumix lighting. So here is non-sensor, normal LED. So our product is 165 watt. So your product, others product is 165 watt as well. So why I claim that others product using 199 unit? Because normally our product using 166 unit. So this 199 will define in this way: 1.2 multiplied by 166. Okay, so it's 199.2. So I did become 199. Why we would claim that? Because our product with the what we call light bars design, so we easily could cover the wider area, extra 20%. So operation hour, I estimate y'all is 24 hour, same for both. So 365 day operation day. So this is non-sensors product, so you doesn't have any sensors saving over here. So we got 72% saving over here. So now we multiply everything, become 287,000 kilowatt. So our product is multiply everything 67,000 kilowatts. Okay, so we multiply with this TNB tariff 0.435. I do an assumption, normally factory is this type of rating. So 0.453 multiply with 287 kilowatt hours. TNB bill is 125,000 ringgit Malaysians, compared to our product 29,000 ringgit Malaysians. So total your saving is 95,000 ringgit per year. Okay, so next we are talking about the lifetime. Normal LED is 50,000 hours lifetime. Ours also same, 50,000 hours lifetime. Why I put 80,000? Because if your operation hour 24 hours, you have to turn on the lighting for 24 hours, which means 5 years you need to change once. Alright, the lifetime for 5 years. But our product got sensors. While nobody does, which means forklift 1, 2, 3, 4, 5 we put over here, then the rest area nobody, it will dim down or switch off. So when dim down, switch off, you prolong the lifetime, right? So I estimate you extra 40 to 50% lifetime. That's why I claim at least you could use 9 years, alright? So if you compare to others, normal lighting, normal LED lighting, 800 per piece, I estimate So with 199 pieces is 159,000 ringgit Malaysia. Our product, good product, never cheap, as you know, right? So 2002 per piece, 166 unit, which means is 365 ringgit, 65k ringgit Malaysia. So let's redo a comparison. So here is the comparison. If you're using normal spotlight, alright, so 159,000 ringgit Malaysia, 1,000 ringgit Malaysia is the LED cost. The electrical cost is 125,000 ringgit Malaysia. So there's a total is 284,000 ringgit Malaysia if you're using normal lighting. If you're using our lighting, initial investment is 365,000 ringgit Malaysia. Then after that, this is what you're buying for. Low energy cost, 29,000. Right, so total is 394,000. So first year you cannot get back. So second year, if you're still using the normal LED, so you're using this energy cost 125,000 minus 29,000 minus 110. So the following year you still cannot get back the cost yet. So until the third years. So which means about 2 years and 1.8 months you get back the return of investment. So this the third year, fourth year, this is your what you call your profit lah, the saving, the energy saving. Okay. So now this is comparing LED to LED only, lighting to lighting. So your ROI is 25 months. So let's write over here. ROI 25.8 months. Okay. So right now we're talking about the scenario number 2. We add up the heat emission saving. So as you know, your the warehouse is for pharmacies use. So normally you should have the air conditioner control to protect your product, right? So I estimate your compressor is 180 horsepower. Why 180 horsepower? Because we got ground floor and first floor. Alright, ground floor and first floor. U and D. Okay, ground floor and first floor. So the area is very big. So I estimate we're using 180 horsepower. So for more details calculation, then you have to give me a data lah. So right now everything I just do an assumption. So per horsepower is 746 kilowatt hours. So the operation hours 24 hours, operation days per year 365 days, TNB tariff 0.453. So kilowatt, you want to change to kilowatt hours, you have to divide it by 1000. Okay, so we multiply everything. So let's redo the calculation again. So 180 horsepower multiply 746 watt multiply with 24 hours multiply with 365 days multiply with 0.453 multiply. Okay, alright. So this is the watts. Alright. So if you would like to change this to kilowatt hours, we have to using this watt divided by kilowatt hours. So this is the kilowatt hours. So we put ringgit Malaysia already. So this is 511,000. Could save 10%. So this is my logic. This is very old light, very old light. So I just use for testing. I turn on this lighting for 15 minutes only. So it heats up to 178 degrees Celsius. So come on, you see, water boiling only 100 degrees Celsius, but this one might heat up to 178 degrees Celsius. Some more, from the Philips data, we could see the metal highlight could heat up to box temperature 400 degrees Celsius. Alright, so this is data says. So you just imagine, if your warehouse you install a lot of this kind of lighting, then you heat up your warehouse. So your compressor have to absorb this kind of heat. So I estimate your compressor never stop. Right? So if you're using our lighting just heat up 31 degrees Celsius when I turn on 15 minutes. But the benefit is that when nobody's there, alright, it will dim down or switch off. So when dim down, switch off, which means it doesn't have any heats. Correct now? So I estimate you could save 10%. This is the logic. Okay? So from that 10%, I do some calculation. This one multiply with what they call 0.1. Okay, so this is the saving. Okay, so this saving I put over here. Everything same. So just now 125,000 ringgit Malaysia, right? So over here 125,000 ringgit Malaysia also same. Alright. So heat emission until here different. Why different? Because I add compressor saving over here. 51,000. Let's see, if I deleted this, then it will become 125,000 ringgit Malaysia, and this one same. Correct now? So for heat emission, I will add up this compressor saving. So let's review again. It will become 176,000 ringgit Malaysia. So your ROI becomes 16.8 months. You see? So this is the benefit from our lighting. So I think that's all. So if you've got any detailed question you want to ask me, so please give me a call. Right? So thank you.